Hello, everybody. So, my name is Len. I do not know how I can follow that awesomeness that just happened. And I was going to make a joke, that man doesn't sleep, but he said that himself. So now is the time where we slow down and go into a much sadder place. So today I'm speaking about a game that my studio, not mine, I'm the lead technical artist there, Heart Machine. We're a small indie studio based in Los Angeles, California. And a few months ago we released this game, Solar Ash. And we employed a set of procedural techniques, and so what I'm going to cover right now is some of those techniques, and in particular, how we met some serious challenges, pain points, trying to implement some of these procedural techniques, mostly in Houdini, and some of the ways that we overcame those challenges. So I also want to call out Chelsea Hash and Carlos Garcia. They were both also technical artists, sometimes technical designers on the project. Much of what I'm going to talk about was done by all of us, and some of it was done by them, and I had less to do with it. So just shout out to them. So this game released in December 2021. This was the second game that Heart Machine has produced. Its first game was called Hyperlight Drifter that was released in March of 2016. And just to kind of give you a sense of where we came from and where we got to with Solar Ash, this hopefully is a little trailer I put together on what Hyperlight Drifter looks like. Should be some audio here too. Maybe. Can it be a little louder, or? Maybe it's just low volume. Okay, so that was Hyperlight Drifter. This was entirely made in this program, Game Maker Studio. So our follow-up to this game, which I'm going to talk about today, Solar Ash, looks like this. And this is the release trailer for Solar Ash. This has a lot of audio. Maybe two.
Continue down this path, and you will suffer, like me. Your every move intensifies my pain. Your blind ambition, all your good intentions. Everything you touch turns to ash! Save anyone, not even yourself.
Okay, so that's the game we went to after Hyperlight Drifter, and this was made entirely in Unreal Engine 4, and of course, with the Houdini Engine added. So Solar Ash was one of the important things I want to kind of emphasize about Solar Ash was that it had a very long development time for what it kind of ultimately was. They worked on it for about 5 years, and part of that was they didn't exactly know what they were going to make. And I came onto this project a year and a half before it shipped, so there was about 3.5 years before that where they were trying things, they were iterating. They knew certain aspects of the game were going to stay in place, but they didn't even know it was going to be a 3D platformer. So for example, the original game, there was going to be zero gravity. The character was going to float around and fly around. Now it's a 3D platformer game. But one of the things that you saw in that video that was a constant was the idea of flow, this idea of a skating flow. The character would be able to move fast, and it would be this sense that you could move from one platform to the other or one building to the other across these clouds, and you could do it if you were at all practiced, and it would kind of have that flow to it, that kind of really cool vibe. So that's going to tie into a lot of what I talk about. So where is the proceduralism in Solar Ash? First, I wanted to mention procedural animation. And the game had these boss creatures, which I think in the final form of the game were called massive anomalies. We called them remnants. And so building these remnants that were going to be these things you jumped on and skated on and you hit these hit points on them, that was a big part of the game. We had, I think, 1, 2, 3, 4, 5, 6, and then spoiler, we had like a final freakish boss creature for the final end game. Looking at these guys, their animation was done entirely procedurally, and I'm going to just mention this very in brief because this was part of the project that I didn't specifically oversee or work on, but similar to what an earlier speaker talked about with physical animation, we could not apply normal animation to these characters because they had to walk around these worlds and they had to take these large steps. Like up here, we had this character we called Trina because she had 3 legs. She had to make these steps that wouldn't like interpenetrate buildings or go through other structures in the world. And one of the things about Solar Ash that was very challenging for us was the designers kind of needed to be able to keep changing things. They wanted to keep relaying out the world. They wanted to make modifications till the very end. So we had to build systems that could accommodate those sorts of changes. We couldn't rely on the world staying static once there was a version of it because there might be a version 2 or a version 3. So the procedural animation, which was largely set up by a very brilliant programmer, Max Kaufman, and some other engineers, accommodated that. Looking at these boss monsters, another thing that we had to accommodate were some of the effects, and this is where Houdini came into play first. Looking at these guys, you can see that there's black regions and white regions, which the white regions were sort of like bone, and we ended up calling these things black mass and white mass. The white mass was supposed to be rigid, and you could skate on it and pick up speed, and you can jump between these bone masses, whereas the black mass was kind of this sticky, climbable stuff. So the next place where proceduralism showed up was in this remnant fracturing. Well, I'll jump back to that in a second, but other aspects that I'm going to talk about after the remnants are islands, black goo, and audio vertices that ended up being procedural. Let me show this video really quick. So this is an example of the dissolve effect that was all handled in Houdini. So this is a test level running in Unreal, where when these boss monsters were defeated, you'd start to see them kind of dissolve or bubble away. And so this was set up largely by Carlos Garcia. This was a really cool Unreal tool that designers could use to figure out exactly how that dissolve would happen. The bone pieces, I don't know if I can repeat this video easily. Is there an easy way to like replay it? Okay, well, just imagine what it looked like before. Oh, hey, great idea. So Houdini would take basic static mesh bone pieces, which are very simple pieces of geometry that either designers or artists had created. There was a bone erosion and weathering tool that would kind of put these pock marks in it, and then that was passed off to another HDA that would then fracture this geometry, and it would write out the pivot painter data along with the geometry, and all of this lived inside of a blueprint in Unreal that the artists could then modify to tweak the tuning. And that pivot painter data then fed to the bone mass so that all those pieces that are floating up could be animated in shaders, so we wouldn't be paying any animation costs for it. The second thing that was involved with these remnant boss monsters that was procedural were these hit points. So here we have Ray, your main character, running along one of these, this is the sword dragger. And there are these hit points that are these kind of glowing things. And you'll notice the bone areas are fractured. And when she hits these hit points, these fracture points would kind of smooth out. They would dissolve. And this was also handled by a really cool system where the artist would place, or the designer could move the hit points. And this again was the point about tuning. We kind of kept retuning the sizes of these bone pieces and the distance between them, and as you defeat a remnant in one phase, the bone pieces would dissolve, and now there'd be larger gaps, so it'd be more challenging. The designers needed to iterate on that quite a bit, so we couldn't just kind of make a tool that would weather the pieces and they'd be a new size. It needed to respond to the designer's feedback, and that's what this tool allowed them to do. Okay, moving on to the next kind of procedural aspect. And the thing that probably caused us the most headache because of the scale were the islands. So the islands are basically these 3D platforms that also supported the skating flow. So their positioning was constantly under tuning. The designers were constantly adding these, positioning them, resizing them, reshaping them. And so they needed to have a very strong iteration loop. In our whole game, there were about 1,270 of these islands across 150 map files. This is where my presentation gets really dull, because I'm going to start talking about things like numbers. Is that a message? Because I'm basically going to start getting into the sad truth of what is it like to try to work on a game where there's 1,270 live Houdini actors constantly wanting to recook themselves across 150 maps that could be opened by any artist or any designer at any time. This led to some challenges. This is a little video showing in Unreal, this is one of our areas called the Iron Root. Buildings, there's these cloud masses that when the game is run become really cool SDF clouds. And here in the outliner, I've just selected all of the splines and live Houdini actors that are appearing in this part of the world. And as you can see, there are a lot of them. All these little platforms, all these little surfaces, these plateaus, those are all Houdini actors. And the idea, first off, they had to live in a set of different biomes. There was a city biome where the liquid was water. There was a forest biome where the size and shape of these islands changed a bit more, had a different look to them, also water. Then in this case, the islands looked differently, but the water was now acid. And then in a final biome, again, the islands have to change their look, and the liquid surface is lava. So the idea of this island tool was that the designers, for the most part, also artists sometimes, could author a perimeter spline, which was the top surface of these islands, and then you just simply extrude them, because it's just a top spline extruded. It's so simple, right? You add some detail. This, luckily, is a very stylized game, so we weren't going for super realistic, where we had to add a huge amount of visual noise. So then finally, designers can go wild. And this was kind of the premise of the game, was that we would have this Houdini tool that would literally make up 90% of the world, and designers would draw a spline, let Houdini go, and we'd have our finished levels, right? And we wouldn't need to do any other work besides what we knew we'd have to do, adding foliage. We did a lot of procedural foliage volumes to add foliage. This is a quick video showing kind of in an Unreal test map how a designer would interact with the tool. They would lay down a blueprint spline that we gave them just to kind of keep things clean. They would drag in the Houdini actor. Then they could hit play and immediately see we've got collision, we've got a shape. It's in a very kind of gray box format right now. It doesn't have any of the look of any of the biomes. This is like the first stage. This is showing basically just, I think this is a video, just showing going into the parameters of the Houdini tool right here. You'll see the gray box pop up. The way I captured it, the little submenu doesn't appear in the capture, but now you're switching it between our various biomes, and this fairly simple island, fairly small too, is changing between all the looks that it needed to take on for the different biomes. This is a quick video showing how that Houdini network worked. This is not like Houdini rocket science. This is fairly basic network to generate this island. So I'll kind of walk through it quick. You have the original spline. It gets extruded, like I said. Then we start to fracture with the Voronoi fracture. And then we start adding cross-lateral fractures. Some cleanup is getting done. Bottom fractures, because sometimes you can see these islands from below, because sometimes they float in space. Some more cleanup, and then I think at this point, we are starting to get the final mesh, and we combine it with collision. So we were using convex decomposition for most of our collision on these. Here's where collision gets generated. Vertex colors get output onto the map as well. We were using vertex colors, and then this is actually the final one with all the geometry interpenetrating collision, vertex colors applied to the island, and that's the idea. So designers started using this thing all over the place, just as we hoped. And it was working fine for a while, but as the number of islands started to multiply and increase, we started to have issues. The first thing was the pandemic was not our friend on this. The day I started at the studio, a year and a half before this shipped, was the day that America shut down for the pandemic. So I never went to the office. My first exciting new day at the job was a few days after sports were canceled and the pandemic made everyone go remote. And so I was in charge of this tool, and now everyone had started using it. They were using it for a little while, but then licensing started to become a problem. And now, I don't know if you've ever done tech support for your grandma, where she's like, I don't know why I can't launch this, and you're trying to explain to her over the phone how to fix her computer. It's like one of the most frustrating things in the universe, is to try to help someone who's not technical fix a technical problem. And we were getting into that. And this really wasn't side effects' fault. This was how do you actually host a bunch of licenses. And then we started seeing the real problems, which is we had these islands that you saw the network. It wasn't that complicated. There's a spline. It's doing some fracturing, but it's amazing. You give a designer the ability to draw the outline of a little island. Somehow they break it. Somehow they draw the spline that ruins the network, and it causes this one little peak function or peak node to go bananas on like 10% of the islands. Oh my gosh. So that was one problem, was that we started to find bugs in the tool, but also these things wanted to cook all the time. And so the minute you enabled the Houdini engine in Unreal, these islands started to cook. And then we had 10 islands, then we had 30, then we had 50 in a single map. And it was basically exploding our machines. It was starting to eat up 64 plus gigabytes just to start cooking these islands. We noticed too that the plugin, which when we started was the V1 version of the Houdini Engine plugin. And just as I came on, there were rumors of this amazing V2. It's coming soon. You could get on the beta program, which we eventually did. And that was a huge win for us. We worked like half the project. I was there on the V1 plugin. We moved to V2. And I'll say the V2 plugin has had its issues still, and maybe still does, but the most important thing ever was that the mesh that Houdini generates was getting stored in the level package of Unreal. The level package is where the level lives. There's a level file with all the layout, and then it can store all kinds of other invisible stuff. It was shoving gigabytes of mesh data into these level package files, and nobody could see it. You couldn't really manage it. V2, they figured this was a big problem, and V2, all Houdini meshes that got baked out started getting put into their own little files, sitting in Unreal. You could see them, you could delete them, you could get angry at them, whatever you needed to do. Huge win. HDA updates was a thing too. So this island tool was now, there were hundreds and thousands of its islands now across our world. So it became like you couldn't just delete these. This was our game. So I had to keep pushing out updates to this tool because we found bugs, we found all kinds of issues. And that started becoming a problem too, because then people were like, well, do I have the new thing or do I have the old version? So what were the solutions? The V2 plugin I already mentioned was huge. Probably the biggest thing was the C++ tweaks. I've done a bunch of C++ coding in another life, in another job, but I was trying to kind of stay away from it. We had engineers, but at a studio like ours, which is very small, you can't always get engineering times. So we started digging into the plugin and changing it on our own. And this was probably the single most powerful, important thing I ever did for the game, was I wrote a editor utility widget panel that basically interacted with new C++ tweaks that allowed us to disable all, so we could enable the Houdini engine and then enable selected. So this saved so much time because we basically disabled all recooking of everything. Seems like a no-brainer in retrospect. But then people could just select a bunch of islands, hit enable selected. It would enable their cooking, and they would basically have to wait only like, a minute or, fraction of a minute to get the islands that they were working on to be live, and then they would tweak the splines, and then they would save the file. But every time a map was opened, that Houdini engine would disable itself again. And that was super important. And there were other C++ tweaks. Disabled by default was probably the most important. And then I also added a bunch of functions in C++ that let me go in and query and change any parameter in any Houdini asset that we had. Previously, this wasn't possible because Houdini actors and the Houdini component inside them are kind of opaque. They don't let you do anything with them unless you're a user using your fingers to click on their toggles. So we added a bunch of blueprint access to them. And then finally, this was something that's kind of like also no-brainer, but I started adding to all my Houdini tools a new parameter, which was the version parameter. It was a label. Maybe there's some cool versioning way to do this, but I literally just added a label parameter called version, and that little label had had something called v0.1, and then parentheses, and then the date. This was the date that I released that tool and said, this is the new version. So now whenever an artist, again, everyone remote, had any issues, I'd be like, that sounds like something I fixed last week. What is the version? This seems like that's not very high tech, but it was incredibly powerful for us because now I could be very clear when an artist had a problem, were they looking at this or that version of the HDA, which was changing pretty rapidly. And then batch Python processing. This was a thing I'll talk at the end if there's time, but we set up a system utilizing Python, which I think is not that used by Unreal people. I don't read too much about it out there, but we found it to be very powerful to scan and analyze the health of our system, including all of the Houdini assets that were scattered through our 150 maps. So for now, I'm going to move on to the final little piece of proceduralism, which was climbable black goo. So it's all throughout the levels. You also saw it on the big remnant monsters. And this is basically kind of the core of our climbing puzzles. And there were basically 258 of these goo actors across our 150 production maps. And they were also live Houdini actors. We couldn't really turn off liveness for our Houdini actors because the designers kept changing. They wanted to keep working. They wanted to keep tweaking. And we wanted them to do that so we could get the best possible product. So this is a quick video showing how the climbable mesh tool, as we called it, they worked. They dropped proxy geometries, which we built so that you could hit G and they would be invisible because they're hidden in game. But they would put them together, then they would drag the Houdini climbable mesh actor on there. Or before they did that, they could, of course, test by just jumping on the geometry because they were set to be climbable. But then they would add the actor. It would then basically voxelize those meshes. And they could throw in any kind of custom mesh they want to get the results. That slime talk totally reminds me of our blobs. And they could modify it all they want. And so kind of walking through the network, it was not a complex network. It basically started with this proxy geometry. It voxelized it. It smoothed it. Then it added a lot of really funky, cool noise to try to get a really cool shape. And then a lot of that funky, cool noise was smoothed away to get a game-ready asset. And then what happened? Oh, and then we dealt with convex colliders. We wanted to use convex collider decomposition from Houdini to make our collision work. This ended up becoming a problem spot for us, a pain point, is that some of our blobs, again, in all of our tests of our little blobs that I did, convex collider counts are 10 to 20, not that bad. Suddenly we're seeing 500 to 600 convex colliders coming out of blobs that designers are all excited that they can create their own using this tool. So that became a pain point. And then someone said, hey, let's quantify all the goo because then we can get all that noise back with lower triangle or quad counts. And so now we had hundreds of these scattered in our levels, but now we had to go and quantify them all with exoside quad remesher because Houdini's quad remesher isn't all that great. So that led to a very important thing, which was the idea of doing a bunch of processing, cleanup, healthcare, if you will, of your projects using Python. And I don't know if you all have been using this for years, but I started using this on my last project and kind of fell in love with it. The key thing is you can launch your Unity editor with your project, solar.u project, and execute a Python script. That Python script scans solar.py. That does nothing. That basically launches a whole bunch of other scripts, but the key thing it can do, which I don't think Blueprints can do, is it can launch levels. It can load every one of those 150 levels. It can scan every actor in that level. And because I wrote those little tweaks that let me read all the parameters from Houdini actors, it can ask questions like, hey, give me a report of all of the goo actors that have a version less than 2.0. Because at 2.1, we added the quantify feature, for example. And we found that this is pretty awesome because it also works very fast. We could scan 150 levels and write reports out or even make modifications in about 4 minutes. So like compare that to a user opening one of every 150 levels in Unreal, for those of you lucky enough to have used Unreal. One of the things we did with Python was generate LODs for our world. You probably saw that we have these floating kind of island, these big floating worlds. Like we had, I think, 5 of them. We needed to merge all those actors together to create a LOD for the distance. You do that manually, it generally fails because there's always weird non-rendering stuff that gets captured in that group. With Python, using a function like this, I could load every map. I could grab a set of actors. I could exclude all the ones that I know cause problems that aren't going to be visible anyways. I merge them, and then I write that merged LOD out and move on to the next map, and it all happens in like 10 minutes. Final thing, and I said the blobs were the last procedural thing, but this is actually the last procedural thing. It's related to islands. Some of the islands are just solid ground, but some of them are acid or lava. So you had a little switch in the island tool that would let you switch to those things. It would change the form, it would change the vertex colors so that we could get all that cool kind of waterfall action coming down. But then at some point, the audio department, which is the most ignored department, they came to me and said, you know what, the audio task of this game is getting more and more horrible looking to us all the time. We're adding all these islands, it's getting bigger, we're not even done yet deciding how big it's gonna be. We don't know how we're gonna build the audio space. We don't know how we're gonna add audio sources to all these things. And a lot of these things, Len, are these weird islands coming out of this weird Houdini tool. Can't you procedurally scatter audio or something like that? And I was like, yeah, I could, right? Houdini can do anything. They're computers, after all. So we looked at how we might do this, and the number of audio sources for like the lava bubbling or the acid flowing or the waterfalls was pretty tremendous. But we figured out that if we could just get a bunch of positions in space, and we only needed like 10 categories, acid, lava, blah, 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 we could basically in C++, in the engine, scan thousands and thousands of positions, and there'll be thousands in this one category, thousands in another, but wherever you are in space, you can easily do a distance and location check to those points. So we came up with this idea that all we need are points in space, so Houdini just needs to get its scatter positions, scattering points on these surfaces to Unreal in some form. And so what I ultimately did was just write a little simple Python node in the island tool. And what that did, well, now I'm getting ahead of I'm not getting ahead of myself, I'm actually mixing this up with something else. I didn't do anything with Python at this stage. What I did was, I was thinking I could just scatter, like you can take points from Houdini and you can instantiate blueprints on those points, you can instantiate anything you want. I'll just instantiate stuff using the standard Houdini thing. It's a live actor in Unreal. The problem is we had thousands of these. There was like 50 on one little island. Do I want to have that many new actors appearing in the outliner? It kind of like was a really bad problem. So what I did, which I thought was kind of clever, was I basically encoded, similar to that version string, I just created 2 new parameters that were audio vertices and audio vertex normals. And when this thing cooked, it scattered all those audio vertex positions, were just points in space, and shoved the locations as a string into those parameters. And then in Unreal, the designer would change the shape of the island. It would re-expand after a few seconds. It would be a new looking thing. It would be working great. Those audio labels would now have the new point positions. So now we just need to get those into the audio system. And so that's another thing we used Python for, was the Python script that would run nightly would scan these fields, go through every 150 maps, scan those fields, pull out the points, and start instantiating, in our very lightweight way, these audio vertices that were basically generating our sound fields. And it worked out great, and we're actually planning to use it. Oh, this is the version field, by the way, that I mentioned. Version 4.26, released in 8/24/21. I'm very happy I do that now. So, again, the Python stuff to help us quantify goo. It basically solved the level LODs issue we had. It basically was scanning and generating all these audio vertices by kind of scraping all of our meshes. And then, as I kind of mentioned before, optimization and health reports. I had it generating Slack reports to all the leads saying, this many things are problematic. This many meshes coming out of the art department in our levels have way too many vertices. These things should not have complex collision. They should be simple. And we could see these lists like get smaller by the day. So they ended up being kind of like task lists for the team. So re-emphasizing, Python has been a great way to kind of keep our project clean when it was kind of getting out of control. And that's basically it. And I just wanted to point out, Heart Machine, that's my email if you want to reach out. And we are hiring. We're very interested in increasing our proceduralism. So we are interested in Houdini artists that can help us go to the next level with proceduralism on our future projects. Thank you very much.
Thank you, that was a great talk. What's the purpose of quantifying goo?
Quantifying goo?
Yes, you mentioned it a couple of times.
It's for the specular hits. So the way that, well, you saw when the goo had all that awesome noise and it was looking really sweet, but then it had to kind of get smoothed out. If you left it with a lot of that noise and it was triangulated, a lot of those cuts and the noise undulations just started throwing the speculars off. And we found out that if you quantify it, a nice sweet quantify, like from Exoside Quantify, it really smoothed those out, but it didn't take any more vertices. And so it was really just a quality of that kind of sheen, if you will.
Have you considered generating normal maps for the, because you kind of had a high poly version at the start. Is that something you guys tried?
Doing what?
Have you considered generating normal maps with all those details in them?
Oh, yeah. Well, yes, and we abandoned it because there was not a single UV in our whole project, and we couldn't start with the blobs. It was basically a style thing. It's a good idea, and I thought about it, but A, you'd have to do like an automatic UV layout, which might have worked okay. But also, it's just kind of the art direction of the game was that it was kind of decided that we didn't need it and we could get away without it, and it would be too much of a hassle, I suppose.
Okay, thank you.
There are no more questions? No. Okay.
Were there scenarios in which you lost work because of between versions where you would rebuild the tools and, I don't know, like some input curve would get missing, or just did you have to redo large sets of manual work?
Oh, yeah. Have to redo large sets? That's a gray area. There were times where the tool would break and I would get mad, like, no, what have I done wrong? And the designer would be like, I already just redid it. And I was like, no, that was my problem to fix. And so they redid some work. But yeah, I can't say that was really an issue. I will say that Houdini at the time, and it had this problem that the input structures that you send in, curves or other meshes, they would go bad a lot of the times. And I found out, little super secret, Control W, that Houdini actor, Control W is duplicate, it fixes it. And you delete the old one and you have all the same settings. Oh my God, that saved us many, many times.
I'll try it next time.
Yeah.
Hello, my question is about the team. When you joined a year and a half ago, you said, and they didn't know exactly what the game was going to be about. So what were some struggles that you had to go through, sort of tightening the focus of the team and the gameplay?
Yeah, that's an interesting one. Well, some of it is kind of outside of my domain of the game because I came on at the year and a half mark when they really were like, we really got to button this down, because they had 3.5 years of that sort of exploration, like if you have tons of venture capital kind of vibe. And I'm probably going to get in trouble when they watch this now that I'm saying these things. I mean, they had the core of what they wanted the game to be, but there was still a lot of exploration. And so in terms of kind of what had to happen, it was really one of those things like real milestones started appearing, and so hard decisions started having to get made. Like, no, we're not going to do that. And some of the stuff I think about now is some of these boss monsters, these remnants. We had some really cool, like crazy scorpion ones and other things that had gotten pretty far developed. And at some point, it was like, there's just no time now. We have to reduce the number that there are. We can get this only so much done now that we have a year and a half, or we're gonna be in trouble.
Is there one more? No. Okay, we are not seeing any more hands. Okay, thank you very much. That was a fantastic job.